Hello everyone, my name is Vinayak, and in this presentation I will explain about the Liquid Galaxy ecosystem. I will cover what Liquid Galaxy is, why it exists, and how its core components work together, and how data flow through the system to create an immersive visualization experience. So the goal of this presentation is to give a clear system level understanding, especially from a contributor's perspective. So let's go to the agenda slide. So here I will start with a brief introduction to what Liquid Galaxy is and the problem it solves. Then I will give a high level overview of Liquid Galaxy ecosystem, including its core software and hardware components. After that, I will explain how data and commands flow through the system, from user interaction to the synchronized display output. And then finally, I'll cover some common challenges and key learnings that are useful for contributor while working with Liquid Galaxy. So overall, the agenda gives a clear roadmap of what we will cover in this presentation. Now we'll go to the next slide. What Liquid Galaxy is. So Liquid Galaxy is an open source immersive visualization system, which means it is free to use, customizable, and built by global community. It is designed to display the content in a very engaging and interactive way. One of the most important feature of Liquid Galaxy is that it uses multiple synchronized screens instead of just one display. All these screens work together at the same time, which creates a panoramic and immersive experience. Because of this, users feel more involved and can understand information in a much better way. So Liquid Galaxy is mainly designed for geological based visualization. This means it is used to explain or visualize using maps, locations, satellite images, and geographic data. For example, we can visualize cities, historical places, climate data, or even space related information in a very realistic way. It is also widely used for education and visualization. So, school, universities, research centers, and exhibitions use Liquid Galaxy to explain complex concept in a very simple and visual manner. So, instead of reading long text, users can actually see and explore the information. So as you can see in this picture, there are multiple screen setup where a user can stand in front of the display and can actually visualize the location and can get a much better idea. So overall, Liquid Galaxy is a powerful system that combines multiple screens, open source technology, and visual storytelling to deliver an immersive learning and visualization experience. Why Liquid Galaxy actually exists? So we all know that single screens have limits. When we zoom in, we lose the big picture, and when we zoom out, we lose the details. So Liquid Galaxy actually solves this problem by spreading information across multiple screens, so the context and the details are visible together at the same time. So as you can see in this picture, the user is looking at the Stonehenge, which is very popular science mystery location. So instead of understanding the location through a single screen, user can get a much better idea through the multiple screen setup. So it also supports collaboration where multiple people can understand and stand in front of the display and discuss the same visualization. So now we'll go to the next slide. Liquid Galaxy ecosystem. So the ecosystem of Liquid Galaxy is divided into different layers, and each layer has its specific role. First is the hardware layer. This includes all the physical components like multiple display screens, computers or CPU, graphic card, cable, or mounting system. These screens are placed side by side to create a wide panoramic view, which is the base of the immersive experience. Now next is our software layer. So this layer controls what is shown onto the screen. It includes operating system, visualization software, and application like maps or 3D models. This layer is responsible for synchronizing content across all screens so everything runs smoothly together. So then we have our network layer. This layer connects all the system using a local network. It ensures all the screens communicate properly with each other in the real time. So when one screen changes, the screen update instantly without any lag. And then finally we have user interaction layer. So this layer This is how actually the user control the system, such as through the keyboard, mouse, mobile devices, touch display, custom controller. So this layer makes the system interactive and user friendly. So overall, these four layers work together to make the liquid system powerful, immersive, and easy to use. Now we'll go to the next slide. Hardware components. So these are the physical components, parts that make the system work. First, we have master node. The master node acts as the brain of the entire system. It controls the whole setup and sends command to all other systems. So whenever a user gives an input, the master node processes it and decides what action needs to be taken. Next are the multiple slave nodes. Each slave node is connected to a separate display screen. So these slave nodes receive instruction from the master node and show up the required visual with the respective screen. This is how all screens stay synchronized and display a continuous panoramic view. Then we have the displays. These are the multiple screens placed side by side in a curved or straight environment. Together they create a immersive visual environment, making the content look more realistic and engaging compared to the single screen. Finally, there are input devices. So these include keyboard, mic, touch screen, or mobile controller. Input devices allow user to interact with the system, such as zooming, rotating, or navigating through different location. So all these hardware components work together to deliver a smooth and immersive Liquid Galaxy experience. Now we'll go to the next slide, master node. So in this slide, I'll explain about the master node. So the master node works as a central control system of the entire setup. You can think of it as the main controller or the brain of the Liquid Galaxy system. All the actions and system decisions are handled here first. One of the key responsibility of the master node is that it sends the command to the slave node. Whenever a user zooms into a location, rotates a view, or switches content, the master node sends clear instruction to all the connected slave nodes. So this actually ensures that every screen knows exactly what it needs to display. Another very important role of the master node is managing synchronization. Since Liquid Galaxy uses multiple screens, it is very important that all of them stay perfectly aligned. So the master node makes sure that all the screens update at the same time without any delays or mismatch. So because of this centralized control, the system feel smooth and immersive, and users experience the visual as one continuous display rather than separate screen. So overall, the master node is essential for coordination, control and synchronization in the Liquid Galaxy system. Now we'll go to the next slide, slave node. So in Liquid Galaxy, each slave node controls one display. This means that every screen in the setup has its own dedicated computer or system working behind it. This helps in distributing the workload and improving performance. So each slave node controls one display, and slave nodes are responsible for rendering visuals on individual screens, and they do not make decision on their own. Instead, they follow instruction from the master node to ensure all displays stay aligned. They render visual content. So display system. So the Liquid Galaxy display system consists of multiple screens arranged either in straight line or curved shape. So this arrangement depends on the available space and the type of experience required. So a curved setup usually feels more immersive, and because it surrounds the user field of view. So one of the very important aspect is bezel alignment. So bezels are the borders around the screen. If they are not aligned properly, the visuals may look broken or disconnected. So proper bezel alignment ensures that images flow smoothly from one screen to the next without any noticeable gap. So when all screens are aligned correctly and work together, they create a panoramic effect. So this panoramic view makes the user feel like they are inside the visualization rather than just watching to the screen. So this wide angle display is especially useful for maps, satellite imagery, and geographic data. So where seeing a larger area at once improves understanding. So overall, the display system is what gives Liquid Galaxy its immersive and engaging visual experience. So software stack overview. So the first part of software stack overview is operating system. Each node, include the master and slave nodes, runs on the operating system that manages resources like memory, processor, and storage. So this provides a stable base for all software to run smoothly. And then next we have the visualization tool. So these tools are responsible for displaying maps and 3D models and other visual content. So this helps transform raw data into meaningful and interactive visuals. So the user can easily understand. The most important part of the Liquid Galaxy is the controller software. So the software handles communication between master and slave node. It ensures synchronization across all screens and manages user command like navigation, zooming, and transitions. So together, this software component work in coordination to deliver a smooth, synchronized, and immersive visualization experience. So as you can see in this picture, also, firstly, the Liquid Galaxy use Ubuntu as the operating system. Then we have VirtualBox, the virtual where the virtual machine actually runs, and then we have Liquid Galaxy controller plus the visualization tool like Google Earth. And in this whole way, the whole setups actually makes it possible to make visualization experience through the display, all the three display which are connected here. So yeah, now we'll go to the next slide. Role of Liquid Galaxy controller. So the Liquid Galaxy controller mainly handles navigation command. This means whenever a user wants to move to a different location, zoom in or zoom out, or rotate the view or switch between different scenes basically. So the controller process these actions. It acts as a bridge between the user and the system. So user and the system. So the controller also communicates with the master node, and after receiving user commands, it sends them to the master node, which then distributes these instructions to the slaves nodes. This ensures that every screen responds together in a synchronized way. And another key role of the controller is to enable user control. So user can interact with the system using different input devices, for example the keyboard, mouse, mobile controller. So these controller software interprets these inputs and convert them into action. And within the Liquid Galaxy environment, because of the controller, the system feel interactive and easy to use instead of just being a static display. So overall, Liquid Galaxy controller plays a critical role in navigation, communication, and user interaction. So this is a very critical part of the whole Liquid Galaxy ecosystem. Now we'll go to the next slide, which is understanding data flow. So in this slide, we'll try to understand how data flow inside the Liquid Galaxy system step by step. So the data flow start when user input initiates an action. This means when a user interact with the system using a keyboard, mouse, or mobile device like zooming into a location or rotating the view. So this input is the trigger point for everything that happens next. And after the input, the next step is command processing. Here the controller software receives the user inputs and send to the master node. The master node understand the command and decide what change needs to be happen across all the system. And once the command is processed, the system moves to distributed rendering. So the master node sends instruction to all slaves. Each slave node renders its part of the visual content onto its respective screen. Because this happens simultaneously, all screens update together, and this smooth flow from user input to processing to rendering makes the entire system feel fast, responsive, and immersive. Now we'll look at the detailed data flow in the next slide. Now, as we can see here in the picture, the user controls the master node through this Liquid Galaxy controller and sends command to the master node. This master node then control its own display and also the slave display through commands, and in this way all these three displays stay in synchronization. Now for example, when a user zooms into a city, the input is captured by the controller, processed by the master, and this master sent this data to slaves and all screens zoom together. So this actually ensures a smooth and consistent experience. Now we'll go to the next slide, screen synchronization. So how actually synchronization is achieved? So synchronization is achieved by maintaining a shared camera position and timing across all nodes. So the master node and both the slave nodes have access to the camera position and the timings. So this actually ensures that every screen shows the correct part of the visualization at the same time. So without this, the system would feel disconnected and won't stay in synchronization. So user interaction method. So user can interact with Liquid Galaxy in multiple ways. This includes our mobile application, keyboard, mouse, or touch-based interfaces like the touch-based displays. So these methods, there are multiple methods. So these all of these methods make the system flexible and easy to control. Now slide 16, example user scenario. So we can see in this picture also, this is a very good example of collaborative understanding through visualization. So we'll try to get a better idea through an example. Imagine a teacher explaining geography. They start with a world view, then zoom into the country, and finally focus on a city. So all screen update together. So it actually helps the student to understand both our global and local context. So this is a very useful tool for education. So now next slide, real world use cases. So as we have discussed, there are multiple real world use cases where Liquid Galaxy is used, and one of the best example is education, as we discussed earlier, and museums. We can use in museums, research labs, and urban planning. So it actually helps people to understand complex data visually instead of just looking at the picture or text alone. Now, common beginner confusions. The first confusion is master versus slave role. So many beginners get confused about what the master node does and what the slave node does. In simple words, the master node controls and coordinates the system, while slave node only offers instruction and render visual on the individual screen, separate screen. The second confusion is hardware versus software responsibilities. Beginners often mix these two. So hardware includes physical components like screen, computers, and cables, while software includes the operating system, which is Ubuntu in Liquid Galaxy case, and visualization tools like Google Earth. And another common issue is synchronization problem. So beginner may not understand why all screen must update at the same time. Even a small delay, like millisecond delay, can break the immersive experience. So this usually happens due to a network delay or misconfiguration for sure. So, and by clearly understanding these common confusion, beginners can learn faster, avoid mistakes, and work more confidently with the Liquid Galaxy system. So how a new contributor can start? So the first and most important step is to learn the system architecture. So this means understanding how the master node, slave nodes, software layer, network layer all work together. Once the architecture is clear, everything else become much easier to understand. And the next step is reading the documentation. So Liquid Galaxy has proper documentation that explain each and everything from setup, configuration, and usage. Everything is explained over there. So reading the documentation helps new contributor like you and me to avoid common mistakes and saves a lot more time during development and testing phases. So another useful step is to observe community discussion. Since Liquid Galaxy is an open source organization, many experienced contributors discuss issues, solutions, and improvements in the community forums, especially in Discord. So, observing these instructions helps beginner to learn real world problem solving approaches. So by following these steps, new contributor can slowly build confidence, understand the system deeply, and can start contributing in a meaningful way. So now we'll go to the next slide, which is our summary. So first, we looked at the Liquid Galaxy ecosystem overview. We understood how different layers like hardware, software, networking, user interaction work together to form a complete immersive visualization system. Next, we discussed the core components. This includes our master node, slave node, and the controller software. Each component has a specific role, and together they ensure smooth and synchronized operation. And after that, we explained the data flow. So we saw how user input travels from controller to the master node and then to the slave node, and where the visuals are rendered across multiple screens simultaneously. And then finally, we talked about the user interaction. We explored different ways how a user can interact with the system. Now we'll go to next slide. So yeah, thank you everyone for listening me and watching the presentation up to here. So if anyone have any doubt, they can post into our Discord group. So Liquid Galaxy has its own official Discord group. So you can join from this link also, and you can find in the description also if this is published on the YouTube. So yeah, for sure, firstly join the Discord server, and your questions are welcome. So yeah, thank you everyone.